Hi everyone. In this video, I'm going to explain about sorting by comparison counting, which is one more sorting technique which uses input enhancement technique. So input enhancement means given some information, given that some input, from that input we are going to extract some additional information, and with that additional information we can solve the problem in a faster. That means by taking less time. So this input enhancement, that's what input enhancement. So it uses space and time trade-off. That means we are achieving time efficient algorithm at the cost of extra memory space. That means here we are increasing the size of the input by taking some extra input, extra memory. Okay, that's what the input enhancement. So now this sorting by comparison counting is also called as comparison counting sorting, or in simple just comparison counting. This comparison counting sorting works in two stages. Okay, so the first stage, the stage one, it counts the comparisons. Counts the what? Comparisons. That means for in the given array to be sorted, each element is how many number of elements are lesser than each element. That count we are finding. So second stage. In the second stage, we are using that count to place the elements. That means placing the elements. This is what the second step. Let us take one simple example. Let us take some randomly. We'll take some 62, 45, 37, 51, then 81, 70. Okay, assume this is the array I need to what? Sort it. This is the array I need to sort. Now, this is the given input. Now from this input, now we are going to extract some additional information. Okay, that's what I'll take one information, that is count. That is what the first step. First stage. What is the first stage? The first stage we are finding how many each element, for each element, how many elements are lesser than that. That we are finding for each element. Now, see here, for 62, how many elements are lesser than 62? 45 is lesser than 1, 37 lesser than 2, 51 is lesser than that 3. That's it. Okay, that means among these three elements, 1, 2, 3, these are the three elements lesser than the 62. This is the count of what? 62. That means the count of 62 is 3. That means there are three numbers. These are the three numbers which are lesser than 62. Similarly, for the next element, now 45. How many elements are lesser than 45 here? See, this is not lesser, this is lesser, not lesser, not lesser, not only one number. So that means count of 45 is 1. Count of 45 is 1. So this is the count for 40. That means only one number is lesser than the 45. Similarly, come on. Next one. 37. How many elements are lesser than 40? No, 37. No elements are lesser than 37. So we'll say 0. Okay. Now come to the next one. Next one. 51. For 51, how many elements are lesser? Lesser or no? Lesser. Lesser 2 elements. Only 2. Okay. Count of 51 is 2. Similarly, come to the next 81. How many elements are lesser than 81? All the elements are 1, 2, 3, 4, 5. 5 elements are there which are lesser than 81. Similarly, how many elements are lesser than 70? See, this is not lesser. 1, 2, 3, 4. There are 4 elements lesser than the 70. So this is what the first stage. We found the count for each element, how many number of elements are lesser than that each element, that we found. This is the first stage one. Now we will use this count to place the input elements in the sorted array. Now for that, let us take, now we'll take one sorted array, my output. Okay, yes. Now I need to place 62 in this position 3. That means now 62 is placed in what position? 3 position. So this is 62. Similarly now 45. 45 I need to place in what? Position 1. Position 1. Okay, so here 45. Similarly what? Similarly now I need to place 37 where? In position 0. Similarly, now I need to place 51 in which position? Position 2. So finally, next one, what? Next 81 I need to place in what? Position 5. 70 I need to store in where? 70 I need to store in position 4. See, array is sorted. This is the output. This is only the input. But for that, I used same size array, I used 2 more extra. That means at the cost of, that means I'm using extra memory, but I'm sorting very quickly. So first stage, just take the count of the elements which are lesser than each element, that will turn count. Then for that, so this count array gives us the information about the position where we need to store the each element in the output array. So this is what the placing element. This is the just comparison counting method. Hope you understood. Now we'll take one simple example. Now first, how to count this one? See, we are human beings. We are having eyes. We know 1, 2, 3, 4, 5. All those things. We can see which is lesser. We can simply count it. But how the processor will do? Processor doesn't have any eyes. It doesn't know how to count, compare. Okay. So now for that, how to do that? So that will go. We'll see through by taking one more simple example. Fine. Simple example, 5 elements we have to sort. I take a repeated elements. Okay, so now you can take any elements. Okay, any example. Now what I will do? See, now first initially what I will take, I need to take one count array. Count that is initially 0. That means I have not counted it. So initially this count array is what? 0. This is initially. So now what I will do, next time I am taking the first element, because first time I have to check, now I have to count how many elements are lesser than 4 in the given array. So by looking at what I can say, lesser than 4, only one element is a 2. So that I have to put. Now that how we are doing. So here I compare this element I compare with this one. Okay. Now for that, I am taking this as ith element, this as ith element, and this as jth element. Now I am comparing a of I less than a of j. This is element is lesser than true. If it is lesser than, which is greater, 8 is greater. So I am incrementing its count. 8. This count I am incremented. Remaining count as it is. Next, what I will do? Next, I will take next element j. So I am comparing what? Next this one. I am comparing with this one. Now 4 is lesser than 2? No. If 4, that means 4 is greater than 2. So I am incrementing this 4 count. Because I need to find how many elements are lesser than that. That means I am going 4 and 2. One element is lesser than this 4. So I am incrementing this count. 4 count I am incremented 1. Remaining elements as it is. Similarly, next, now I incremented j to next position. So then I am comparing with what? 4 with 4 only. 4 is lesser than 4, false. What I will do? That means now I am incrementing 4 only. 2, 1, 0, 0, 0. This one incremented, remaining as it is, I kept. Next, I incremented j, take the j to the next position and compare again this first element with the last element. Now, 4 less than 8, yes. Which is greater? 8 is greater. So, I am incrementing its count. 8 count is what? Right now 0. I am incrementing that. So, 2, 1, 0, 0, 0. Now, this is my count. This is my count after what? Pass 1. That is when I is equal to 0. Similarly, now I need to do for remaining elements. Okay, let us take remaining elements. What? So, remaining element, now again, say 4, 8, 2, 4, 8. This is my what? Given array. We can. So next I find out how many elements are lesser than 4. Now I need to find out how many elements are lesser than 8. So I am taking this one. So this is my I and this is my j. So first what I did, I compared with these two elements. So now this count only, now this is the previous count, this only will continue. Okay, now 8 less than 2 false, that means 8 is greater, so I'm incrementing 8 count. Earlier 8 count is 1, so that I'm incrementing become 2, remaining count as it is. So next what I will do, I will compare this 8 with this 4. That means I'm taking this j here. So again, 8 is less than 4 false, 8 is greater. So I'm incrementing 8 count. So there's 3 remaining element as it is. So next I am incrementing next element. So j, I'm comparing with this element. Now 8 is less than 8 false, so that means it is not lesser, so this only I will increment, so this become 4001. Okay, this is the pass 2, that is when I is equal to what, 1. This is the first position, this element. Okay, so similarly now this is my count, this is my count after the pass 2. Okay, this is my final count after what, pass 2. This is my count. So next again same thing I need to do. So now I need to find out how many elements are lesser than this element. So I will take 4, 8, 2, 4, 8. Index. So now I am finding this one. Now this is my I. Now this is my j. I'm comparing these two. Again continue from this count. Now I'm checking 2 is less than 4. No, 4 is greater. So I'm incrementing 4's count. 4's count is right now it is 0. Now it becomes 1. Remaining element as it is. Okay. So next this is 0 only. This is 4 only. So this is I'll carry like this only. So this is 2, 4. So next. Again, I am comparing with the last element. So 2 less than 8, false, 8 is greater. So I am incrementing 8 counter. 8 counter right now is 1. So this becomes 2. So remaining count as it is. Okay. So this is our what? Pass 3. This is when I is equal to what? 2. So that means, see, there are no elements. See, final count of 2 is what? 0. That means there is no element lesser than 2. Okay. So this is my what? Final count after I is equal to 2, that means pass 3. Next what I have to do, I have to find out how many elements are lesser than 4. So again I'm rewriting the same input just for you to make you to understand. So now I am taking this element, this is my I, this is my j, I'm comparing these two. Now right now this is my count. So now 4 is less than 8. Yes, that means 8 is greater. So I need to increment 8 count. Right now 8 count is 2. So that I'm incremented. So remaining element as it is. Okay, so this is my final count. Final count array. Okay, so this is my final count array. If you observe, see how many elements are lesser than 4? 1 and this one 2. How many elements are lesser than 8? 1, 2, 3, 4. 4. How many elements are lesser than 2? 0. How many elements lesser than 4? Only 1. Okay, how many elements lesser than 8? This I took 1, 2, 3. See, this is the final count array. Now this I need to place in the final sum array. So sum array, how to write? So sum array is so simply place this, okay, 4, element 4. This 4 element count is what? Finally 2. That means write 4 in position 2. That means position 2 means in this position write 4. Similarly, next 8. What is the final count of 8? Final count of 8 is 4. That means write 8 in position 4. Next, 2. Element 2 final count is what? 0. That means in position 0 write this element. So next 4. 4, the final count of 4 is what? 1. That means write 4 in position 1. So final 8. What is the final count of 8? Position 3. So write 8 in position 3. So this is my sorted array. Okay, this is how our comparison counting sorting works. Now, whatever we did in the diagrammatic format, now same thing we will convert into algorithm. See, this is the name of the array I have given, and parameter to be passed is array to be sorted. This is my input array. So that I have given a pass as a parameter. First, what we did, we initialize this count array as 0. This is my first step. Initialize count array as what? 0, 0. For that, now I will write. Okay. To initialize that one, I'm writing for I is equal to, from where to where return? From position 0 to what? Position, last position what? N minus 1. That means from I is equal to 0 to N minus 1. What we did? We did count of I as what? 0. This is just for initializing the count array, this for loop. Okay, next. Now what we did, here I did passes. How many passes? See, pass 1, pass 2, pass 3, and this is my what? Pass 4 actually. Okay, this is my pass 4, that is I is equal to 3. So for 5 elements, there are 4 passes. For 10 elements, 9 passes. 100 elements, 99 passes. For n number of elements, n minus 1 passes. So n minus 1 passes, but since I started I from where? 0. So next I is equal to 1. If you observe, I is equal to 1. Next I is equal to 2. Next I is equal to 3. I stopped here only. I have not selected the last item. That means I stopped taking I from the last position. Suppose see, if you started instead of pass 1, pass 2, pass 3, pass 4. Instead of pass 1, if I read pass 0. So this becomes pass 1. So this is pass 2, pass 3. See, 5 minus 2. 5 minus 2 is last 3. So that means, see, I stopped I at the last but one position. So what I'll write, so now for I is equal to 0 to n minus 2, do this. That means we stopped at the last but one position, I. So now for j, from where I started j, in the first pass, I started from position 1, I is 0, j is 1. We started here. In the next pass, I is 1, j is 2 started. So next pass 2, I is 2, j started from 3. In the next pass, I is 3 and j started from 4. That means wherever I is there, in front of I, j we started. In front of I, j started. In front of I, we started j. In front of I, we started j. So that means, so this comparison for j is started from in front of the I, means wherever I is there, plus 1. In front of I, to what? See, in all the cases, we stopped j at the last position. See, j last position, j last position, j last position. So j to I plus 1 to n minus 1 do. Now what we did, we compared this element, that means a of I less than a of j. If it is lesser, I'm incrementing the jth element. Suppose this is, for example, see, this is 2. 2 lesser than this one. Yes, we incremented this jth one. Jth one we incremented. If it is not ith one, we incremented. So I'm writing if a of I less than a of j, then what we did? We incremented count of, if it is less than j, we incremented jth. Okay, count of j is equal to, we incremented count of j. That means whatever count of j plus 1. Else, if it is not less, we are incrementing count of I. Count of I. Okay, and for. Now this is whatever written these two for loops. This is for the stage 1. That means to get this final count. We did this code. Now what we need to do? We need to place each element of the array in the final output array, that is S. For that I have used one more for loop. See, from where do I have to store? From 0 to n minus 1. So for I is equal to 0 to n minus 1, what we have to do? See, this element, what is that element? This element is what? A of I. This A of I stored in what? This position. This position what? Count of 0. Count of 0 in what? This is give the this position. So I will write S of count of I am placing A of I. And for finally return yes. That's it, the algorithm. So this is to place the each element of the input array using this count in this position in the final array. This is what the algorithm. Since we have two loops, so we will get n square. The time complexity of this is n square. See, now we will do the analysis. In the analysis, see, the two for loops, we did in so many algorithms, okay? So now let us write, I will do in this space. So time complexity is equal to, see, for this for loop, I is running from 0 to what? N minus 2. And this loop is running from j is equal to I plus 1 to n minus 1, 1. Okay, this is nothing but I is equal to 0 to n minus 1, n minus 2, upper limit minus lower limit plus 1. Now you replace I value by first time 0, then it becomes n minus 1. Next, plus summation, plus I value 1 means minus 1, minus 2. So like that it goes n minus 3, like this goes on. It keep decreasing, n minus 1, n minus 2, n minus 3, keep decreasing. At a time 8, 2 plus 1, 0. Now this is nothing but n into n minus 1 by 2. This is nothing but n square minus n by 2. This is nothing but n square by 2 minus n by 2. So here most dominant term in n square. So time complexity of this is belongs to, this is the, because here for however we give the input, we have to do this one. That means there is only average case. So big theta of n square. This is the time complexity of this algorithm. Hope you people understood this. If you have any questions, please write it in the comments. Thank you. Thanks for watching.